Hey guys, so today we're going to do some long division, and no, I'm not talking about elementary stuff, though I might be starting out with a problem to remind you of the steps of long division, but we're doing it with polynomials, okay? So let's remember how to long divide here. So the first thing we want to do is actually divide or ask ourselves how many. So how many 23s go into 3? None. How many 23s go into 33? 1. Okay, that was our first step. Then we multiply. 23 times 21 is 23. Okay, our next step is subtraction. So we subtract straight down and we have 10. And then we bring down and repeat this all over again. Okay, so our next step would be how many 23s are in 105? And there are 4. Then we multiply 4 and 23 and get 92, sorry. Okay, and then we subtract straight down and we get 13. Okay, now elementary, we used to say 14, remainder 13. More sophisticated, we started going 14 and 13 23rds, right? We would write it as a fraction. Okay, so this is the idea that we're doing today. Of course, it's a little bit more complicated because we're dealing with variables. So let's make sure that we go through and take our time. Okay, so right here, this is what our problem is going to look like. What we are doing here is we're taking this top numerator here and dividing it by our denominator. Remember, our denominator is our divisor, so that's what's going out in front, and then we have our numerator on the inside. Now, remember, it's how many or what do you multiply by? So we ask ourselves, what do you multiply x by to get to 4x squared? Well, I would multiply 4x, okay, to get there. The reason why we want to do that is because we want it to cancel, okay? So next step would be to multiply. So 4x times x is 4x squared, and 4x times 2 is 8x. Okay, and then we subtract straight down, so on and so forth. Okay, so if we took this process, and we'll do a better example in a minute, but this is written here for you. As you can see, when we get down, we have a remainder 5. Now, more sophisticated, right? So what we're going to do is we write our result, which in this case is 4x minus 5. And then our remainder is a positive 5. And we put it over our divisor. Okay, so we're going to do this process little by little. You can always come back to this example because it's written now, but we are going to do some examples together right now. Okay? So we have this 2x squared minus 5x minus 12 all over x plus 4. Okay, so divisor on the outside here. And then on our inside is our numerator. So 2x squared minus 5x minus 12. Okay, so we're going to multiply. What do we multiply x by to get to 2x squared? Well, that would be 2x. Okay, now we're going to actually multiply the divisor. Okay, so 2x times x is 2x squared, and 2x times negative 4 is a negative 8x. Now, this is where it gets tricky, okay? Because right here we usually subtract, but I don't know about you, but negative 5 minus negative 8, we all like to do things in our head even though we shouldn't. So what I like to do is remember subtraction is like changing the signs, distributing the opposite, right? So what I like to do is take another color and say, let me change the signs. Because once I change the signs, now I can think about addition, okay? So negative 2x minus 2x is 0, and that was the whole point. We wanted that to cancel. Negative 5 plus 8x is 3x, and then we bring down the negative 12. Okay, let's repeat our steps again. What do you multiply x by to get to 3x? Well, I multiplied that by 3. Okay, so let's multiply the divisor. 3 times x is 3x, and 3 times -4 is -12. Again, we're subtracting straight down, but it could be confusing. So what I'm going to do is change the signs and add. Okay, so if I add straight down at this point, because I changed the signs, those canceled, that was the point, and -12 plus 12 is 0. So what this is saying in the long run is our answer is just 2x plus 3 with no remainder. When there is no remainder, that means it's a factor, right? So it goes into nice and evenly, right? So if division has no remainder, it's a factor. It can be broken up. Awesome. Okay, next step. What is this example different? How is it different than the first one I just did? What do you notice? Well, hopefully you're saying, wow, it's an x cubed. That's a good start, right? Because our other one was an x squared. There's also something else going on here. It's missing a term. So I want to identify that this one's missing a term, because when it's missing a term, you need to make sure that you put that term back in. Okay. Well, if it's missing it, what does that actually mean? It means that it's 0. So watch this. Our divisor is x minus 3. And we have x cubed. Now, what are we missing? We're missing an x squared. What that means is we actually have a 0x squared. And then we have this minus 4x plus 7. Now, with long division, the reason why we put in that missing term is because it makes all of our setup, our format nice and easy. Okay. Otherwise, we'd be off with combining like terms, because I can't add an x squared and an x, right? They're not like terms. So this allows the format to be a little bit nicer. Okay. So let's go through our process. What do we multiply x by to get to x cubed? Multiply it by x squared. Because x squared times x is x cubed. And x squared times -3 is -3x squared. Okay. I'm going to change the sign so I can add. So that becomes a negative. That becomes a positive. Now I'm going to add straight down. Again, if you like your subtraction, go for it. Those cancel. That was the point. So we're left with 3x squared. And now we're going to bring down our -4x. Okay. What do you multiply x by to get to 3x squared? Well, I multiply by a positive 3x. 3x times x is 3x squared. That was the point, right? Excuse me. 3x times -3 is a -9x. Again, now we subtract. If you want to subtract, go for it. If you want to change the signs to add, that's up to you. These cancel. We're left with 5x. Bring down the 7. Okay. What do you multiply x by to get to 5x? Well, I multiply by 5. So 5 times x is 5x. 5 times -3 is -15. Okay. I'm going to change the signs to add, because I like adding better. Those cancel. That was the point. 7 plus 15 is a 22. So I have a remainder here. Now remember what we did with the example on the other page and how we write our answer. So the first thing we're going to do is write down that division on top. So x squared, plus 3x plus 5. Now it's a positive 22 for the remainder, and the remainder always goes over the divisor or the denominator. Okay, and this will be our answer. One more example just to make it a little bit different. Okay, what's so different about this one? Okay, we have an x cubed. Looks like all of our terms are there. But what's different in this case is, hey, you know what? I'm going to make this an x cubed or 3x. So it's not just x. Okay, so how does that differ? Technically, it doesn't differ much. It just makes an extra add-on. Okay, so we have 3x plus 2 as our divisor. And then we have 3x cubed plus 5x squared plus 8x plus 7. Okay. All right. Ready? What do you multiply 3x to get to 3x cubed? Well, I just multiplied by 3x squared. Now, if you write the wrong thing down, you should notice because you won't get the same value here to cross out, okay? So x squared times 3x gives me 3x cubed. And x squared times 2 is 2x squared. Okay, I'm going to change the sign so I can add. So that cancels here, and 5 minus 2 is 3x squared. Bring down the 8x. Okay, 3x times what is 3x squared? Well, that is just x. 3x times x is 3x squared plus x times 2 is 2x. Straight down. I'm going to change the signs, right? So I can add. So okay, that means these cancel. And 8 minus 2 is 6x. Bring down that 7. 3x times what is 6x? Well, that would be times 2. So we get 6x plus 4. Again, I'm multiplying that 2 times the binomial here. Okay, change my signs. So I can add. These two cancel, and that's great. And 7 minus 4 is 3. Okay, so I have a remainder 3. So technically this binomial is not a factor. So, but my final answer according to this division is x squared plus x plus 2. It's a positive 3 all over our divisor, our denominator of 3x plus 2. And we are done. All right, let's see what practice we can do.